Now let's see this question. It's saying that what are the types of regulators shown in the following figures. Now this is the regulator here. If you see here, there is a spring here, and there is a plug for this valve, and this spring will phase or will be working under a pressure, taking out from the outlets of this regulator and return back as feedback to the diaphragm above this spring and will press on it. If the pressure is balanced between this here and the pressure coming from outside, this one will stop. If any one of them less than the other, it will let this plug move against it. So if the pressure here is higher, this will move down. So we can say this type of regulator is called self-compensating pressure regulators with externally connected spring load regulation. Why spring? Because the load here is applied by spring and it externally connected the outlet of the pressure regulator, not by an internal air circuit or air connections systems. For the second one, if you see here, there is a spring here and this adjustment nail screw here to change the load of the spring. So it's loaded by spring also. It's loaded by a spring. So this one is called self-compensating pressure regulators with spring loaded. And there is no external or internal connections, just only loaded by spring and manual adjusted. Now, the next question, fill the blanks. يقول لك the following figures show a control valve. Now this is the control valve. See here, the pressure will comes here, will raise this diaphragm up, and the spring will resist the movement toward up. The air here, if you apply it, that means the diaphragm will move up opposite the gravity direction, and the plug here, if it is moved, it will close if it is moved to the gravity directions. Now, say this one, its motion mechanism, it is linear. It is linear motion mechanism. The following figure shows the control valves. Its motion mechanism is linear. And it is a globe valve. You see here, it is globe type. The actuator is direct acting because it's move. The actuator is not direct acting, is move reverse acting. Reverse acting because move against the gravity. Reverse acting actuator. And the body is direct acting because it's moved to the same direction of the gravity, but the actuator will move to the opposite direction of the gravity. So the direction flow, as you see here, if the flow comes from here, it will push up to let it go. So the flow direction here is flow to open. The resultant acting or actions of this component will give a fail close type. That means if the pneumatic signal, the instrument air signal, is cut from the actuator, this will lead to close. Lead to move the travel to the closed position, and if you see here, the travel does not reach to the full opening, so the travel does not go to the full travel, or the stem does not go to the full travel, which means the actuator is exposed to the bench set. Now the next question. There is equal percentage globe valve has maximum flow coefficient equal 368 meter cube per hour, and its lower flow coefficient is 56 meter cube. What will be its flow coefficient at 2.3 centimeter level if its full span is 5.7 centimeter? Now we have here a globe valve, and it has a characteristic equation. This characteristic equation is now for the equal percentage as CV equal the CV maximum multiply the rangeabilities to the power x minus 1. This one x mean to indicate for the travel. Rangeability, it is the ratio between the maximum CV and minimum CV. We'll substitute this one ratio here, 368 over 56, and it gives me 6.571. This is the rangeability for this control valve. And we need to find the percentage of the travel. It's given to us here as a centimeter, as measurement or metric dimension or engineering units, but we won't find it in percentage. So by using the two-line method, we found that 2.3 over 5.6 and multiply 100, it gives me 4107 percentage, or we can say just only 0.4107 travel value, no percentage here. Then by substituting them in the equal percentage characteristic equations, it gives me this one, 368 multiply 6.5 to the power 0.4107 minus 1. Of course, this one will change it up, down, side down. It becomes this one in the denominator. And it will give us the final result, which is 121.343 metric cube per hour. Now, the next question. If the previous valve, the same valve here, the same information, but the trims are linear, what will be the flow coefficient in the same given values? Okay. Now, we will see this one. How can it work? CV minus the CV minimum over the CV maximum minus CV max minimum, because it's linear. And here the travel rate minus the 0, because the minimum travel rate is 0 and the maximum is 1, which is correspond to the 100% here, minus 0. So just by using the two-line method, it gives me this way, or you can say CV multiply x to the 1 minus the rangeability inverse plus the rangeability reverse. We can use this one, which is easier in calculating the value, and it will give me 184.13. See, different value of CV, because we change the characteristics from equal percentage to linear. And this is the equation. You can find it by this equation or the other equation. Choose as you like. Now let's go to the here. Choose the correct answer between the parentheses. If a glove valve is connected to a positioner, it means the valve is. When you say here a positioner, normally with the plants, they don't use positioner for only one on-off purpose, because it's costly without benefit. We can just utilize the cheapest device, which is solenoid, simple solenoid, very cheap, and it can give me the same job, the same function. So most of the practice, and commonly when they say there is a positioner, that mean I'm using positioner for throttling or varying type of valve traveling. If the valve has actuator with double acting piston, but double acting piston, there is two pneumatic input signal inside the case of the piston. It means the actuator will receive one pneumatic signal, no, two pneumatic signal, because one for the opening and one for the closing, to open or to close the body. If it is said that the valve has PN equal 90, we know that this is standards used in ANSI, ANSI standard, American standard for the valves, and when you say that 990 in PN mean nominal pressure, and that lead us to use the pressure unit, which is bar, not millimeter. The same thing here, 9 bar, not millimeters. Now, other question. Complete the following drawings for valve instrument air lines hooks up diagram that shows the track of pneumatic signal at energized case and at energized. Now here we have these drawings and this one drawings. What is the difference between them? Here the electric signal with 24 type to energize. Now he want to energize what? This device. And here is the signals to energize this signal. Type. The instrument air flow stream through the magnetic tube at energized situation. Now we have here energized situation. That's mean this situation it is energized, and here in this situation it is de-energized. Okay, just simply we will use what? The solenoid valve. Now we can see here the instrument for energize case. This one is solenoid valve. It's a three-way solenoid valve, should be button here. And if it is energized, as is mentioned here in the situation, E for energizing, D the energizing, E mean there is a volt, E, D there is no volt, 0 volt here, DC, and this one the signal becomes 0 or becomes 24, on off situation. That comes from the air regulators and will go through the E pass here to the positioner or to the actuator here to put the piston move down, or to let the piston move down. And the de-energized case in this one, because here is de-energized, I mentioned here the same thing, E for 24, D for 0 voltage, solenoid valve on off. See here, E, if it is E will this one run, if it is D this one will run. Now the vent, the air will comes to the vent, not coming from the air, will go outside from the actuator to the vent or to the exhaust. So this is the solution for this type of question, that's solving the control valve. Thank you for listening.